Welcome back to the second lesson of week 3. In this lesson, we're going to look at the idea of binary overflow. That is what happens when the result of a sum is too large for the available storage. So in this lesson, we'll look at what overflow is, and we'll look at how overflow can occur when you add numbers and overflow can occur when you subtract numbers. Let's recap briefly about the range of numbers. Unsigned binary numbers, that is ones that don't use the 2's complement system, can range in value in a single byte from 0 to 255. That would be if all the positions were 1. 2's complement has the same range, but it's in a different place. It's from minus 128 to plus 127. It's the same amount of numbers, but they're differently organised. Now, of course, real computers string multiple bytes together, and therefore they have a huge range of numbers that they can represent. Nevertheless, you will eventually reach the limit of the allocated space for a particular calculation, and so all computers have to deal with the problem of overflow. Because we're working with single bytes, we can look at overflow and learn about overflow, but obviously a real computer wouldn't overflow when it reached 255. So what is overflow? What causes overflow? Overflow occurs when the computer, for some reason, needs to store or process a number outside of the available range for the space that it has allocated for a calculation. That number might be positive or negative overflow. That means that it might be a number that's too big of a plus number or too big of a minus number. Later on, when we do fractions, we'll learn about how it could be a fraction that's too precise. That's actually one that you probably come across more often, truncating a fraction. And we'll see overflow occurring when we do an addition or subtraction, and we end up with a carry bit at the final, the most significant end of the calculation. We've got one last carry bit and we've got nowhere to carry it to. And that's probably the most common time that we'll see overflow. So we're going to look at overflow with addition and subtraction. So let's look at overflow with addition first of all, which is the most straightforward example. And you can easily imagine how this occurs. If the two numbers that you add together add up to more than the available storage space, in this case that will be bigger than 256, or in a 2's complement bigger than 127, then you'll get a carry bit and it won't go anywhere. So let's just look at a simple example. Two unsigned binary integers. Remember what I mean by an unsigned binary integer. It means the most significant bit is a positive number. We're not using 2's complement. So look out for that terminology in the exam. And here are two numbers. They both fit happily into the available space, but when we add them up, 0 and 1 is 1, 1 and 1 is 0 and carry 1, 1 and 1 is 0 and carry 1, 1 and 1 is 0 and carry 1, 3 ones are 1 and carry 1, 1 and carry 1, 0 and carry 1, 0, and yes, you know it, carry 1, and there's nowhere to carry that 1 to. So our calculation basically has gone wrong. And the result, if we worked out what those three numbers were, 182 plus 123 equals 49. I mean, clearly wrong, and overflow has produced that error. It's not overly often that that comes up in the exam, but it is quite an important principle in binary maths. And the same thing can happen if we're using 2's complement numbers. So here are two positive 2's complement numbers, and we're adding them together. How do we know they're positive numbers? Because there's a 0 in the minus column, the minus 128 column. So we're adding two positive numbers stored using the 2's complement system. And let's just do that sum. You can see me going through, not as many carry bits this time. Okay, so a carry bit in the 64's column. So we carry that across, and that puts us a 1 in the minus 128 column. And that's a problem because we've carried from a positive to a negative column. That 1 represents minus 128. So the result of our calculation is that 54 plus 89 equals minus 113. And again, clearly an error. Now, this wouldn't happen in an ordinary computer once you got past 127. Instead, this is the result of us using a very restricted storage just for the purposes of learning. But the idea of overflow can apply to any computer. And of course, overflow can also occur if you're using subtraction. For example, if you subtracted a very large positive number, you then turn that into a large minus number and add it, and that would cause an overflow of a negative number that is too large to store in the available storage. However, in some cases, some overflow is normal and ends in the correct result. And rather than try and explain it here, looking at the starter screen, let's go and look at some examples. So before we look at the examples, let's just remind ourselves how binary subtraction works. Binary subtraction means adding a negative number. So 13 minus 6 is the same as 13 plus minus 6. So in order to do binary subtraction, we convert the second number to negative and then we add the two numbers together. We did that last presentation. If you're not clear about that, go back and have a go. So here's an example. I thought it'd be nice to look at an example of subtraction without overflow. Supposing you were presented with that question in the exam, two binary numbers. As it happens, I don't know if you can tell, the second number is larger. That means we're going to end up with a minus number as our result. And if you were shown that question in the exam, what's the first thing that you'd do? And if you, by the way, if you just want to do this subtraction now, before I do it on the screen, I think that would be quite a good way to practice. Anyway, I'm going to pause a second and then I'm going to continue. So continuing, the first thing you would do is convert the second number to negative. I've just done it for you because I want to get onto the idea of overflow and so on. All right, so there's the second number is now negative. I flipped all the bits and added 1, and I'm sure you can remember what the next step is, but if you want to have a go at it now, the next step is to add the two numbers together. So I'll do that. I haven't gone through it step by step. Remember to show the carry bits, and I've ended up with a quite small minus number. Remember, in 2's complement, if there's a lot of 1s in a minus number, that means it's a small minus number. And if I work out the value of those three numbers, it's 86 minus 92 equals minus 6. So it's worked absolutely fine. And the reason it's worked fine is because my second number is larger, so my overall answer is a minus number. Now let's look at the other type of result that we might get. If the second number is smaller than the first, so if you're doing like 8 minus 2, you'll end up with a positive answer, won't you? The result is a positive number. In that case, there is an overflow bit, but it's not an error. It's just the way 2's complement corrects the top bit to prevent it from being minus. Once again, perhaps looking at an example will help to embed it. So here's an example, and I don't know if you can see, but the second number in this case is smaller, so we're going to get this overflow effect. we convert the second number to negative. I'm going to do it for you, so pause the video if you want. I'm going to go ahead in a second. So there it is. I flipped all the bits and added 1. And now you know what's going to happen on the next. And so continuing with this subtraction, we now add the two numbers together. So let's just quickly do that. Going through each column, showing the carry bit where it occurs. And in this 64's column, 1 and 1 is 0 and carry 1. So in the minus 128 column, we've got two 1s. We add them together, that's 0 and carry 1. So we've got a carry bit. The minus column has reset to 0 and we've got a carry bit. In this instance, that is not an error, and it's easy to prove that's the case because let's convert those three numbers to decimal. 86 minus 60 equals 26. So that is the right answer. So in this instance only, where when we're subtracting a smaller number from a larger one, and so we end up with a positive integer as our result, then a carry bit is a natural part of the calculation. If just to go into it a bit deeper, it's how the computer resets the minus column to 0 so that the overall result is positive. So do be careful with that. If this happens in the exam, if you're ever doing a subtraction of this type and you get that overflow bit, you could circle it, you could write next to it overflow not an error or something like that. And it does, this one actually does come up relatively often in the exam, and it does catch students out. So because this is a bit of a tricky concept, let me go back over it again. If you're doing a binary subtraction and the second number is smaller than the first, then your result will be positive. When this happens, an overflow bit will occur, but this is not an error. In this case only, it's not an error. It's how 2's complement ends up resetting the negative bit to 0. Don't worry too much. If you can do everything else and you just flub that last bit in the exam, that's probably 1 mark. So don't overly panic about it, but it'd be great if we all got that right. So to recap, you should now understand what overflow is and the circumstances where it can occur. Overflow from an addition is always an error, whether you're using unsigned integers or 2's complement. And just to make things a little bit more complicated, overflow during subtraction is not always an error. So look out for that one. I'm leaving you with a test, and you're going to go through every step of it. 2 decimal numbers, turn them both into binary numbers, then turn the second one into a negative, then add them together. And you'll see that in 2 cases you'll end up with a positive result, and in 2 cases you'll end up with a negative result. And I'm sure you can work out in your head what the correct results are. So then convert your results back into decimal and make sure you ended up with the right result. Okay, so this is the end of what we're doing about binary subtraction, and we're going on to more complicated binary concepts in the next lesson. Bye for now.